This is problem 27 of chapter 16 from the textbook Stats Modeling the World, 2nd edition. Okay, so we've been told that if you buy a dozen eggs, apparently, at least from this supplier, that the mean number of broken eggs is 0.6. So if we say let x be the number of broken eggs, in a dozen, okay, so then we can say that then what we've been told is that the expected value of x is equal to 0.6, and the standard deviation of x is equal to 0.5. Okay, so question A, how many broken eggs do you expect to get? I guess that's if you buy 3. So we want to know, and this is the tricky part, resist doing this, 3x. The textbook might actually do that, but I don't like it and I don't recommend it. What I would do is think about the event. So what's happening is you're buying 3 dozen eggs, and then you're buying 3 dozen eggs, and then you're buying 3 dozen eggs. So the event is actually happening 3 times. And that's important when you start to figure out the variance. So I see it like that. Okay, so I would start that way. That helps me anyway. Then you can say 3 times the expected value of x if you want. And so then it's 3 times 0.6. So that's going to be 1.8. Okay, so now B, what's the standard deviation? Okay, so if we said the standard deviation of 3 times x, that would be wrong. And then what we would do is we'd say 3 squared. But what that says is that it was scaling the purchasing of buying 1 dozen eggs. That's not really what's happening. We're buying a dozen eggs, and then a dozen eggs, and then a dozen eggs. So that's equal to the variance of x plus the variance of x plus the variance of x. And so that's going to be 3 times the variance of x, which is 3 times 0.5 squared. Okay, so now to find the standard deviation, we can say that the standard deviation of x1 plus x2 plus x3 is equal to the square root of 3 times 0.5 squared. And if you want, you can go to your calculator. 0.5 squared times 3 equals, and the square root of that is 0.87. So let's say 0.87 eggs. Okay, so C, What assumptions did you have to make about the eggs in order to answer this question? Well, the cartons of eggs that you buy must be independent of each other. So each dozen eggs are independent. Okay, so that's how you do this problem. Good luck.